Hello. So today I'm going to be showcasing a piece of code that I've been working on over the last 2 or 3 days. This code's called Castle. So essentially, I'm going to show you very in-depth everything about this code. I literally just finished like some of the finishing touches on it just now, right before starting. All very fresh in my mind. So first of all, we have our main.cpp file, we have a troop file, a castle file. First I'm gonna go ahead and show you guys the castle file. So the castle file essentially has this data down here. It has the F defense, which stands for front, like front door. We have a W defense, which stands for wall defense. We have a food storage, F storage, castle damage. This can be tweaked later on, but I have it just set up in the constructor to a base value. But we have a list of troops. So if we have a list of troops, we have a class troop. Troop has the data values, health, hunger, status. There's 3 statuses. Alive, which is 1. Farmed, which is 2. Dead, which is 0. Then they have a damage, just a base damage of 5. Nothing in the destructor here. These pointers for this, the way I've done it. So we have our display, which shows they're alive. They're in the, if they're alive and in the castle, on the farm, and dead. If it's 3, this is kind of extra because we actually removed it from the list, so that's alright. So we have a lot of functions in the castle at each file. We have all of our base functions, just get and set functions right here, so I'm not going to go over those. Add troop, which is just used to push a pointer of a troop pointer into this list. So when we make the troops, we do that. So we have a castle battle function, which takes health. I'll go over this more in depth in a bit. Which gets attacked the front or the wall. Damage, which I'll go in depth in main for that. And then just enemy count, the amount of enemies. Troop battle. So the way I actually coded this, my idea was you have a castle with a defense, and randomly get attacked sometimes, and which spot that gets attacked is random too. And the wall on the front. Your castle fights back with like catapults, whatever. And it does damage basically to the masses. And if the masses still get through your castle, your troops end up battling them. So this only gets initiated if the castle battle is lost by you. And each troop, fights until they die, and then the next troop fights, and it goes on like that. Then we have a hunger step. This function basically just goes through the troops that are alive, takes a random amount of hunger off them each day. Inside of that, if their hunger is below 0, sets it back to 0 and takes some health off. Display, this is just basically going to show us all of the troops and their status. The troops, call this in a switch in main, and feed troops to farm. This is going to send troops to a farm that I have. This is kind of extra. I'll explain it more in main. Troops to castle. This is just the opposite of this. Return to the castle. We have average hunger, average health. This is just used for output. So I think I'm going to start by showing you guys the main. So we have art display, a function I made here. Basically it takes a file, takes a string art, opens a file. While it's not the end of the file, it gets a string line, outputs it, and line. Void new screen. This basically is because we're dealing with a lot of embedded while loops, just because this program is definitely not optimized, but it's just a cool program using a list of pointers and whatnot and a bunch of classes. Just a fun little game type thing. So I'm not too worried about optimization of it, but this is to help so you can actually see what's going on. Menu, these are our options. So we can fortify the gate, very basic, because we have whatever. Fortify this, it's just basically putting more into this. And then we have fortify walls. It's the same. Send troops to farm. Basically, we have a class farm as well. And the class farm simply has a couple data points, which are like seeds, food, and troop count. And it's so basic. I don't even need to show you the farm class. Then we have check farm status. It just checks the status of it. You guys will see what I mean by the farm stuff. It's all inside of main basically. Return troops. It just brings it back from the farm. And gets food with them. So these three are kind of paired together. Send troops on the hunt. This just gets a random number, basically, and puts it into like the food storage. Feed troops. It just feeds all the troops, and we'll give it what you want. Okay. So first of all, in main, we have to create our castle. We call it user castle. Just create an instance of it. Then I create a farm. User farm. These are all default set to 0. The 3 data points. Seed count. Count, troop. That's all it is. That's literally all it is. So, seed counts generated. So, we created a pointer of a troop called new troop. Create a list of troops, a troop list, an iterator for it. And then we have some random generated things that are used. This is used to figure out how much is added to the defense. You do a function. This is used for how much food returned on the hunt for this one. This one's used basically a 1 in 16 chance of your base getting attacked. Each iteration of this loop. This is the amount of troops that attack you, 5 to 15 if this happens. This is which gets attacked, your wall, your door. This is the damage the troops do each attack, so it's not the same. And then this is basically your defensive damage. This was something I did earlier. I'm not using that anymore. I just have it set up in Castle 200. That was something I originally. So here we have a bunch of integers that are just used basically as storage. I declare them out here because I don't want to, inside of the loop, have to create a new instance of a each time that the loop runs. Also strong. First, I ask how many troops. This is just so it's actually kind of more of a simulation game, and you just see in it here. These also should just be up. So then I just see out some art. Use my function to display art. Don't art files, just a castle art. Pretty cool. We create the amount of troops that the user wants. Your troop equals new true base here. Set the ID, the I. Also is the ID for troop. It's just 1 through whatever. And we don't really use it for anything. So it's just kind of for if I ever want to go back and add stuff. We add it to the castle list. Push it to our list in main. That's it for that. New screen, so we could see that. So who on farm is set to false, which makes sense, right? You're not on the farm, you start off on the castle. Farm timer 0. You're not on the farm, so the farm timer should be 0. That's what I mean by the farm stuff's all in main. Very basic. We just set a input something not X, start the loop. A live counter is equal to 0. So this basically is this right here. Make sure that while this is running, you have living troops in the castle. If you don't have living troops in the castle, whether that be because they died from starvation or they got killed in battle, it will basically end the program if you do not have troops. This just iterates through our list in main that we've pushed back to. And if the status is not 1 or 2, if there's not at least 1 person with that, then we're gonna go ahead and return 0 and just say, okay, there's no one in the castle to defend. So after we do this, we do a hunger step. Alright, so it might be honestly better to do the hunger step before this. Let me think about this. So we put the hunger step before it. Yes, I think that would be better. But if not, we'll see. So basically the hunger step just goes here. I'll show you guys a hunger step function now. So other than display, which is just iterating through and showing each person, right? The person, the display function, it just shows their health, whatever. hunger step basically takes a hunger loss dice, health gain dice, a dying hunger dice, and it goes to the list, and it gets these three things. And if you're either alive on the castle or alive on the farm, your hunger goes down by default by this hunger dice. It should be anywhere from 7 to 13. And if you're dead, it sets your health, or not if you're dead, if you're hungry, so below 0 for hunger, your health starts to deplete by between health dying 20 to 30, so a lot. And then we set your status to 0 for hunger, or not your status, your hunger to 0. Because I don't want it to be impossible to like, have troops heal back if they're losing health. And then if the health's below 0, they die. We set their status as dead. And then essentially right here, if status is not equal to 0 and the hunger is over 95, so if they're alive and they have over 95 hunger, which by default their hunger is 90, means they're well fed, we start to boost their health up a tiny bit, 3 to 8. And we just iterate through it. So that's what hunger step does. So now we basically, all of this is a hard part of the code. It's essentially what happens if we get attacked. So we have an attack dice that gets rolled on the 16, and it goes here. It equals 1, so there's a 1 in 16 chance, and we start the attack. First we get the amount of enemies here. We get the enemy health, so 90 health per enemy times the amount of enemies equals mass health in integer. And then we get which one gets attacked, a door or wall. Then we get the damage per troop, the mass damage, which is just damage per troop times the amount of enemies. And then we just, okay, if it's 1, we tell them, okay, the wall's under attack by this, they do this much damage. If it's 2, the door's under attack by this, it does this much damage. So after that, we essentially have this function here, castle.cpp function, that it takes the health, which thing's getting attacked, it takes the amount of damage they're doing, it also takes the enemy count, and it basically returns a new mass health. So if new mass health, it's like, this is basically the castle battle I was talking about earlier. I'll pull it up. Castle battle. So in castle battle, we put in the mass health, which is getting attacked, the amount of damage they're doing, and the enemy count. So we start the battle. Okay, while battle is equal to 1. If it's door, then we do this. Wall, or yeah, no, if it's the wall, we do this. Wall's under attack. I did this much damage to the wall, and we defended with whatever. It just has all this stuff here. This little calculations, pauses, shows you, and then it just loops, right? And if our building falls, we essentially return we basically return the health that was returned. But if the health is less than 0, which means our castle defended properly, this won't ever happen. It'll just go here, say, okay, we defeated the enemies, new screen, and it just closes this. But if not, that means we have to, okay, our castle fell, we have to fight with the troops now. So we start the troop battle. The troop battle takes this new health, so the amount of health that was left between all the enemies combined, the enemy attack, so how much damage they're doing for each attack, and it takes the enemy. And if the value is equal to 0, we return 0 and the function ends. So this one's a little complicated. So we have enemy health, enemy attack, troop count. We basically get a fatigue factor. This just makes the damage unique, takes it away from the enemy, makes it a bit easier for us. We have all of this here, and we start the iterator of the troop list step again. We set I equal to 0 also. So I equal to 0 is the amount of enemy troops that have been defeated. So essentially, I gets incremented each time that someone's defeated. But I think there's something wrong here. Let's see. So, no, there's not. So, y is less than troop count. We go here first, and we see, okay, is the person alive first, and our troop alive? If they're not alive, they can't fight. We count it, right? Okay. We take the counter, we increment it, and then we keep going until we can find someone that is able to fight. So, because if you're on the farm, you can't fight, and if you're dead, you can't fight. So we keep looping through this, and essentially, if the counter right here, which is starting off equal to 0, equals list size, which right here is just returning the size of the troop list, that means that none of our troops are able to fight, so the castle gets defeated, returns 0. This function returns 0. The val, if val equals 0, it actually returns 0 on the whole program. That's it. So that's the first little thing. So if this gets us the iterator finds us a troop that can fight, okay, cool. We start the battle. Battle equals 1. While battle equals 1, we start this fight. So we have the troop damage, which we get from basically just going to the iterator, get damage. It should be 5. Enemy health we get from up here. We set it equal to what was passed in. Just a temp extra base enemy health gets stored right here from what gets passed in. So we can keep setting this. So I'm gonna try to explain this. So it probably sound like I'm talking gibberish. So basically up here we have 2 variables that are the same thing: troop health and base enemy health. So, or not troop health, enemy health and base enemy health. We pass in enemy health and we set base enemy health equal to it. Then we don't touch base enemy health at all. This stays the same. This is constant. Enemy health gets changed. So when we start this loop, enemy health gets reset to what we had made constant earlier, the base enemy health. Each troop has the same health. We start the battle, and then we get the fatigue factor. We subtract the damage. Well, first we don't subtract the damage. We get the fatigue factor. We get the health of our troop. We get the enemy's health after we attack them. So enemy health minus troop damage, or our 5 damage or whatever that we get from up here. Then we set our health to basically our troop health, which we get from up here, or no, troop health from right here, minus the enemy attack, so what they hit us for, and then plus a fatigue factor. So the fatigue factor, essentially just, it's like, I could have added this to the enemy damage, like, enemy damage equals enemy damage minus fatigue factor. I just put it in the set our health. I figured that'd be easier, even though it's not logically it's good, but that's alright. So does the same thing. So then inside of this loop, if the enemy health goes less than 0, we display the troop that beat him, increment the I, which means, that's 1 enemy down. Because the entire loop starts with I is less than troop count. So we see out our troop has defeated enemy I, enemy 1, and then the battle equals 0. So this loop ends right here, starts back up here, gets through this, right? Finds a troop that can fight, gets here, gets this, starts a new battle. Okay, then we start the battle. Say this time, oh, our troop actually gets defeated this time. Else, if our troops get health is less than 0 or equal to 0, our troops died. Their set status is 0. And then we get the val. We get our ID just to see out. Okay, troop ID has been defeated by enemy troop. And then we increment the amount of troops that we've had defeated. We go to the next troop, and we restart the battle, and it starts again. And then basically if our list size, which is just the amount of troops in our list, equals the counter of dead troops right here, that means all our troops have been defeated, so we return 0. And that comes right back up to here, where if this equals 0, we return 0, and it kills the whole program. But otherwise, this should run until the troops are done fighting, and then return 1 if the troops aren't all killed. And then that's it for this right here. And then this is if the castle wins. I already showed you that. So that ends the basically the attack on the castle, which was kind of the hardest part to figure out. These took forever to figure out how to like actually make it work, because erasing stuff from a list can get kind of sketchy. But right here, this is for the menu. we just get the average hunger of each troop. We have a function that does that down here. Let's get past the farm stuff. All it literally does is it has an integer of hunger, a troop counter, and an average hunger that's equal to 0. We just go through the list, we just calculate the average. Real basic. Same with average health. You can take your time to read this. I'll pause for like 10 seconds. It should make sense. Alright, so basically we get these and we see out, alright, use your castle, our defense, our wall defense, our food storage, our average health of troops, which we get from those functions, the average hunger, which is a bit or so now this is a farm stuff, right? So we've had all the back end stuff here, all the troops are alive, making sure they're all alive, making sure there's not a battle that occurs, figuring out the battle, who wins, mixing up the troops and stuff, the list, and then we output, okay, this is what the average hunger is, the castle, and then our defense and stuff after all the battles and whatnot. So now we get to this. If on farm equals true, which on farm only equals true if, in the switch statements, we choose to send troops to farm, which is C, right here. Testing to see if troops are already at the farm, right here. So basically, on farm is already set to false in the beginning, if you guys remember. So this will run the first time you do this. So you will go ahead and call the function troops to farm, which if we come up here, all we do is ask how many troops you want to send to the farm, put them in. You get the available troops in the troop size, and if we tried putting in too many troops, it doesn't actually send that. So I need to actually fix this. So if you guys are paying attention, you'll see that there is some logic here. So we're returning troops gone, and it's 0. And when we call this here, troops to farm, we still set troops to farm, even though we're returning 0. So it will send 0 troops to farm, and we'd have to return 0 troops to farm to return them. So to fix this, what we're gonna do is we're gonna go ahead. Let me think about this. So, well, I'm not gonna worry about it. For the moment, we'll come back to it. Put a comma here, because it's really minor. So, other than that, it should all work good. But we send the troops to the farm, we set the farm troop count, we get the seed count, which is randomly between this, right? We take this and we multiply it by the amount of troops we send to farm, and that's how we get the seeds. The seeds after 5 days, which is what this original counter thing is up here, will blossom into food, and then you can return the troops and return the food with them. So basically, we get the true amount of seeds, set the seed count, we set on farm to true, so now the troops are on the farm, so this won't run next time they run it, and then next time anyone does this, it'll just display the farm. Case D just displays the farm, checking on the farm. Case E is to return them, so it's the polar opposite of what I just showed you. Case F just looks into the forest with RNG for food. I'll give you guys a second to read this. It's just using those original int uniform distributions in the beginning. Case G feeds the troops, so we call the feed troop function, which I'll show you right here. It'll be up here. We ask how much they want to feed the troops. We go ahead and make sure they have enough food. If not, or if they do have enough food, we come down here. We feed them however much they put in divided by the amount of troops. So, and then we take it from the food storage. So that's basically it. And then there's just a new screen function. So after each loop, you're able to do whatever. And then that's it. I haven't showed you guys the person or the troop.h file. I haven't showed you guys even the farm class, but the farm class is kind of similar to this one. There's not really anything there. The constructor with all of these set to 0, a destructor, and then a display that just shows assist. So let's run this. Hopefully everything works good. Let's full screen it. How many troops? We're gonna make 10. Welcome to Castle by Cody, Rabie. Door defense, wall defense, food storage, average health, average hunger. So our options are fortify gates, fortify walls, send troops to farm, check farm stats, return troops from farm, and feed troops. We're gonna fortify the gates. We've increased it by 17. Alright, let's fortify the walls. So we've increased the walls by 28. Let's send troops to farm. We're gonna send 4 to the farm. So we have 328 seeds on the farm, 0 food, but 4 troops on the farm. Looks like our hunger's starting to get low. Let's go ahead and feed all our troops, and we're gonna feed them 250. So troops 1 through 10 have been fed some food. 4 troops are on the farm, the rest are at the castle. Let's go ahead and check the farm status. So it's still seeds at the farm. We'll send some troops on a hunt. Got 9, not a great hunt. Got 18. Let's go ahead and fortify the front wall. Now let's actually try to return the troops to the farm. Troops have returned with food farmed. We have 328 new seeds, so now we have 505 food. And you can see the farm is now empty here. So we have 505 food storage. We're gonna go ahead and let's actually feed our troops. Looks like our hunger's at 18. We're gonna feed them 450. So that's a bit better. It looks like the hunger's kind of up for us now. I think we should send some troops back to farm. I think I'm gonna send 8. That's a lot of seeds. Now we should actually beef up our defenses, because if we get attacked, all our troops are on the farm, and that will not be good. Looks like our health's starting to go. I'm gonna get some stuff. Let's return our troops from the farm. So now we can see our average health is actually going down a good bit, and our because our hunger is like none. So we're gonna go ahead and feed our troops, and we're gonna feed them a lot, 1,000. See that? The hunger is way up. So we're gonna go ahead, send some more troops to the farm. Just need some more food still. Let's see. We'll send 4 this time. Perfect. Let's fortify a gate. Now we're under attack. Okay. So the door is under attack. So the door got chosen by 8 troops with level 5 damage. The attacking troop health is 720, and they did 40 damage. Keep in mind, this is the sequence of battles between our castle and the troops, not our troops and their troops. Because if our castle falls, then we have to fight them with our troops. So it just basically goes through the attack. Attacking troops have been defeated. Castle defense is boosted by 50. Castle defense has defeated the attacking enemies, and we're back to normal. So I think we should we'll hunt and we'll return our troops. Oops. I returned the troops too early because I didn't check. So we're in a bit of trouble now. We're gonna probably our best bet to do this and hope we don't get attacked. Let's feed the troops. And we got attacked. That's not good at all. So we got attacked by a level 14 troops with 7 damage. And it looks like they busted into our castle. Our troops suit up for battle with the remainder of enemies. All of our troops were at the farm, so we have no available troops, and our castle fell. So that's the program. There's a couple other iterations that could happen there, obviously. If a battle goes down, it basically, I'll actually do this right now to demonstrate it. If a battle goes down, make this 2. and they actually bust through. It's pretty cool. Perfect. Okay, so the troops busted through. So our first troop, he took out 1, 2, 3. He took out 3 enemies. No. Alright, yeah, he took out 1, 2, and then he got defeated by the next troop. And 2 took out 1, 2, and 2 got defeated. So we can see what happens. So essentially, a lot of our troops died there, it looks like. And if we go to feed them, we can see that. In the list, we only have 6, 7, 8, 9, 10 that are left in the list. So, that's that. I want to see what happens when we get attacked again. So, I'm going to go ahead and wait. Perfect. That's what I wanted. So, the first 4 cannot fight because they are dead. So, 6 fights until he can't, and then it keeps going. Looks like our troops actually held in there. So, let's keep going. And it looks like none of them can fight because they're all dead. And then they got defeated. So now our castle undefeated as well. So that's a program, guys. I'm gonna go ahead and link the GitHub link to this. I'm sure I didn't explain it well at some parts. This code took me a long time to code. I did it in like the last 2 days, so it's not like I spent like a ton of time really conceptualizing it. I just kind of had the idea and wanted to roll with it and code something up with it. But it does work, and I probably explained some of it kind of bad, so it might be more useful to just look at the actual code that I'm gonna link. But I think it's a cool piece of code. I think it utilizes a lot of things that form with some basic concepts and some very easy things a pretty unique and cool program. So hope you guys enjoyed. I'm gonna go ahead and link the thing below, the GitHub to it. If you guys want to check out the other 2 classes I didn't show, feel free to. They're very basic. It's just got the constructor in it and nothing really else. But or to look at something I may have skimmed over and not gone over as well, feel free to check that out. I'm gonna scroll through the main right now. Feel free to pause at any point, check something out. Once again, this is not fully optimized or anything. I just finished it right before this video. I'm sure I'll change some things up on it, but for now, I'm happy with how it's looking. And I'm glad I got all the kinks figured out. That's what was bugging me. It was doing stuff, but then it would crash after a while. I had no clue why, and I had to figure out the kinks. And I finally got it all to work, and basically it won't crash unless you type in, like, when it's asking to switch for a character, or like right here, like I'll type in D or something, like, I mean, oh, no troops. It won't even crash then, because we have the thing to test it. So, like right here, maybe it'll crash here if I do like this. No, I mean, it literally will not crash. So, I have it. It's a nice program. Check it out. It's not anything crazy, but it is cool. Uses some cool concepts. But that's been all, boys. God bless. I'm gonna link the GitHub below. Feel free to leave a comment or anything. If anyone even watches this, I doubt anyone will even watch this video. I have like 5 subscribers, but I want to post the stuff I work on, even though I'm a year into computer science and whatnot. But things cool. So that's all. God bless. Stay safe, everyone. See you guys.